Our Milky Way galaxy is vast, spanning over 100,000 light-years across. However, it is dwarfed by the colossal galaxy IC 1101, stretching over 5.5 million light-years across. IC 1101 is located about 1 billion light-years away from Earth in the constellation Serpens. It resides at the center of the Able 2029 galaxy cluster, a dense collection of thousands of galaxies bound together by gravity. The discovery of IC 1101 is credited to the English astronomer William Herschel in 1790. At first, it was misidentified as a nebula, a cloud of gas and dust. It wasn't until the 20th century, with advancements in telescopes and astronomical techniques, that the true nature of IC 1101 as a galaxy was revealed. Observing IC 1101 is like looking back in time. The light we see from this galaxy has traveled for 1 billion years to reach us. IC 1101 is classified as a supergiant elliptical galaxy. Elliptical galaxies are characterized by their smooth, oval-shaped appearance and lack of spiral arms. They are thought to be the end products of galaxy mergers, where multiple galaxies collide and coalesce over billions of years. IC 1101 is estimated to contain up to 100 trillion stars, making it one of the most massive galaxies known. To put this into perspective, our Milky Way galaxy contains a few hundred billion stars. The galaxy's core is thought to harbor a supermassive black hole, billions of times the mass of our Sun. This black hole's immense gravity governs the motion of stars and gas within the galaxy's central region. Its vast size and mass also influence its gravitational pull, attracting smaller galaxies and pulling them into its embrace. Unlike spiral galaxies with their distinctive arms, IC 1101 appears smooth and featureless. This is typical of elliptical galaxies, which are thought to have lost most of their gas and dust in past mergers. Without the raw materials needed for star formation, elliptical galaxies are primarily populated by older, redder stars. Despite its smooth appearance, IC 1101 is not a uniform blob of stars. Observations have revealed a complex structure within the galaxy. It is thought to possess multiple shells and streams of stars, remnants of past galactic mergers. The stars within IC 1101 are not evenly distributed. The galaxy's core is densely packed with stars, while the outer regions are more sparsely populated. This distribution of stars reflects the galaxy's formation process, with mergers playing a significant role in shaping its current structure. The stars within IC 1101 are predominantly old and red. These stars have long since exhausted their nuclear fuel and are in the later stages of their stellar evolution. Among these ancient stars, there are also populations of globular clusters. Globular clusters are dense, spherical collections of hundreds of thousands or even millions of stars bound together by gravity. These clusters are thought to have formed early in the universe's history, making them valuable tools for studying stellar evolution in the early universe. While most of the stars in IC 1101 are old, there are hints of recent star formation in some regions. This suggests that the galaxy may have acquired some fresh gas and dust through interactions with smaller galaxies. The sheer number of stars in IC 1101 is mind-boggling, far exceeding the number of stars in our Milky Way. At the center of IC 1101 lies a supermassive black hole. This black hole is a cosmic monster, billions of times the mass of our Sun. Its immense gravity dominates the galaxy's central region, influencing the motion of stars and gas within it. The presence of a supermassive black hole at the center of IC 1101 is not unique. Astronomers believe that most, if not all, massive galaxies harbor supermassive black holes at their cores. These black holes are thought to have played a crucial role in the formation and evolution of galaxies. The supermassive black hole in IC 1101 is actively feeding, creating a bright, energetic region known as an active galactic nucleus, or AGN. The AGN at the center of IC 1101 is not as bright as those found in some other galaxies, suggesting the black hole is not accreting matter as rapidly. IC 1101's colossal size is not the result of internal star formation alone. This galaxy has grown to its enormous proportions through a process known as galactic cannibalism. It has consumed countless smaller galaxies throughout its lifetime, adding their stars, gas, and dust to its own. Evidence for this galactic cannibalism is seen in the faint shells and streams of stars surrounding IC 1101. These structures are remnants of past mergers, the stretched-out remains of galaxies that were torn apart and incorporated into the larger galaxy. As smaller galaxies are pulled in by IC 1101's gravity, they are stretched and distorted by tidal forces. Stars are ripped from their parent galaxies, creating long, faint tails that stretch out into space. Over time, these disrupted galaxies lose their identity, their stars becoming part of the larger galaxy's halo. While the visible matter in IC 1101, such as stars, gas, and dust, is impressive, it only accounts for a small fraction of the galaxy's total mass. The vast majority of IC 1101's mass is thought to be made up of dark matter, a mysterious substance that does not interact with light or other forms of electromagnetic radiation. Dark matter's presence is inferred from its gravitational effects. Astronomers observe that galaxies rotate faster than they should if they were only composed of visible matter. This discrepancy can be explained by the presence of a halo of dark matter surrounding the galaxy, providing the extra gravity needed to hold it together. In IC 1101, the dark matter halo is thought to be particularly massive, extending far beyond the visible galaxy. This halo acts as a gravitational well, pulling in smaller galaxies and contributing to the growth of the galaxy cluster. IC 1101, like all other distant galaxies, is moving away from us. This is not due to any peculiar motion of the galaxy itself, but rather a consequence of the expansion of the universe. The space between galaxies is stretching, carrying them apart like raisins in a rising loaf of bread. The expansion of the universe was first discovered in the 1920s by astronomer Edwin Hubble. Hubble observed that the farther away a galaxy is, the faster it appears to be moving away from us. This relationship between distance and velocity is known as Hubble's law. The expansion of the universe means that the light from distant galaxies is stretched as it travels through space, causing redshift. IC 1101 has a significant redshift, indicating that it is moving away from us at a considerable speed. Observing a galaxy as distant as IC 1101 requires powerful telescopes and advanced imaging techniques. Ground-based telescopes face limitations due to atmospheric distortion, which can blur images of distant objects. To overcome these limitations, astronomers have turned to space-based telescopes, such as the Hubble Space Telescope. The Hubble Space Telescope has provided stunning images of IC 1101, revealing its structure and morphology in unprecedented detail. These images have been instrumental in advancing our understanding of giant elliptical galaxies and their role in the universe. In addition to optical telescopes, astronomers also study IC 1101 using other wavelengths of light, such as radio waves and X-rays. By combining observations from different telescopes and wavelengths, astronomers can build a more complete picture of IC 1101 and its surroundings. Studying IC 1101 provides astronomers with a unique opportunity to learn about the formation and evolution of giant elliptical galaxies. These galaxies are thought to be the end products of galaxy mergers, and IC 1101's extreme size and mass make it an ideal laboratory for studying these processes. By analyzing the galaxy's structure, stellar populations, and dynamics, astronomers can gain insights into the history of galaxy mergers in the universe. They can study the remnants of past mergers, such as the shells and streams of stars surrounding IC 1101, to understand how these events shaped the growth and evolution of galaxies. Furthermore, IC 1101's location at the center of a massive galaxy cluster provides clues to the role of environment in galaxy formation. Observations of IC 1101 and its surroundings help astronomers refine their models of galaxy formation and evolution. IC 1101, located billions of light-years away, offers a glimpse into the distant past. The light we see from this galaxy has traveled for billions of years to reach us, carrying with it information about the universe as it was when the light first embarked on its journey. By studying distant galaxies like IC 1101, astronomers can trace the evolution of galaxies over cosmic time. They can observe how galaxies have changed in size, shape, and star formation rate over billions of years. These observations also help constrain cosmological models, providing clues to the nature of dark matter, dark energy, and the expansion history of the universe. As we continue to explore the cosmos and develop more powerful telescopes, we can expect to uncover even more secrets hidden within distant galaxies like IC 1101.